on, we have learned how to apply Torcaso on the angle theta, where theta is between 0 to 90, which happens in the first quadrant. Right, so in the first quadrant, if you were to draw your right angle triangle, okay, so your sine theta in the first quadrant, so your sine theta is a positive value. Your cosine theta will also be a positive value. Your tangent theta will be positive value. Okay, where your theta is between 0 to 90. So the trigo ratio will be all positive in the first quadrant. So what we are going to examine is what happens if this angle theta move on to the second quadrant, third quadrant, fourth quadrant. Will the trigo ratio still be all positive values? Okay, so what we need to do is we need to imagine that you have a circle, a unit circle. What does unit circle means? A unit circle means you let the radius be equals to 1 unit. So let radius equals to 1 unit. Okay, and then you need to imagine that you are this little point here called P, and you're actually traveling in this unit circle in the anti-clockwise direction. All right, so we are done with the first quadrant, which is between 0 to 90. So what's going to happen now is that this little point here is going to travel all the way and come to the second quadrant here, right? So the right angle triangle form will be in this way. Okay, so if you look at this point here, then we're going to let this point have the x coordinate as x, y coordinate as y. But if you travel to the second quadrant already, if you look at this diagram here, if you tie it to the coordinate geometry, then on the left side of your y-axis, there will be a negative x, right? If you were to recall, remember when you draw graphs, then you label your axis, this will be all positive. Then on the left hand side will be all negative. If it's above the x-axis, it's all positive. Below the x-axis is negative. Okay, so we use the same concept, right? And then the y coordinate of this point is y. It's positive y because it's above the x-axis, and it's a unit circle, so we let the radius be 1 unit. Okay, so let's see what happened to the ratio. So second quadrant, sine theta. To find sine theta, it's getting the length of the opposite side over divided by the length of the hypo. Okay, let's label all the side first. So the angle theta now, this is your angle theta. So this will be your adjacent. This is your hypo, and this is your opposite. Okay, right. So opposite will be y, and then your hypo will be 1. So sine theta is equals to y. Okay, which is still positive, right? Still positive. So positive. Then if you go to tangent theta, tangent it's okay, never mind. We find cosine first. Let's do it in order. Cosine theta, so it's a over h. A will be negative x over 1, negative x. So that is negative value. And then tangent theta, it's O over A, which is a y over negative x, which is negative y over x. So this is a negative value. Okay, right. So if you look at the second quadrant, the only positive trigo ratio you can get is sine theta. Okay, if the theta is between 90 to 180, then sine theta will be positive. For sine theta and tangent theta, you will get both negative value. Okay, so let's highlight the letter S. S is the one that's positive. Okay, I think we better circle it and not highlight. This one doesn't work. All right, S. Okay, now let's go on to the third quadrant. Okay, I need to erase this because I need more space. Let's go on to the third quadrant and see what happened. Okay, let's draw the diagram. Okay, so you have this little point here that travel to this third quadrant. Okay, so that is your angle theta now. Right, so this is negative y. This will be positive x, 1 unit for the radius. So third quadrant, tangent theta will be ratio O over A, which is negative opposite. Oh, sorry, adjacent is also negative because it's on the left side of your y-axis, so negative. So negative y over negative x. So give you y over x, which is a positive value. And then sine theta will be O over h, which is negative y over 1. So negative y is a negative value. Cosine theta will be a over h, which is negative x over 1. Gives you negative x is a negative value. So in other words, if you look at the third quadrant, only tangent of the angle between third quadrant is between 180 to 270. 180 to 270. Okay, only tangent of angle theta between 180 to 270 gives you a positive value. Alright, for sine and cosine, you end up getting a negative value. Okay, so you do it the same for the for the fourth quadrant. So the little point now move to the fourth quadrant. Let's see what happened to the fourth quadrant. Okay, so below the x-axis, so this will be negative y. You're on the right hand side of your y-axis, so positive x. Unit circle 1 unit, meaning the radius is 1 unit. Okay, so from here, let's find this is fourth quadrant. Let's see what happened. So tangent theta will be O over A, which is a negative y over x. So negative y over x, so negative value. Sine theta will be O over h, which is negative y over 1, negative y, negative value. Then cosine theta will be A over h, positive x over 1. So x positive value. Right, so you realize that cosine of angle of cosine theta, where theta is between 270 to 360, is a positive value. Okay, for sine and tangent, they are both negative value. As the result from all this finding, right, okay, we can have a conclusion. And the conclusion is, in the first quadrant, trigo ratio is positive. In the second quadrant, only sine ratio is sine theta is positive. Third quadrant, only tangent theta is positive. Fourth quadrant, only cosine theta is positive. So one way to remember is in the anti-clockwise direction, you can remember it as at the letter A, then sugar, the letter S, 2, letter T, coffee, letter C. So how can you make use of this concept you have learned? So that will be in the next few slides. Okay, so now we are ready to draw the diagrams. We have two specific angles here, angle A and angle B, and both angles are in the second quadrant. All right, you are told that here they are in the second quadrant. And also another important thing to take note is that you're supposed to find the exact value. So what does exact value? Exact value means your answer should not have a lot of decimal places. Like exact values is in third form. Like for example, square root 2, right? Square root 3, pi, etc. These are called exact value. Okay, you're not supposed to have a lot of decimal places behind. Then that's not exact. All right. So we need to draw the diagram. First of all, to draw the diagram, because we're finding trigo ratio, so trigo ratio is linked to Tuakaso. So we have to draw a right angle triangle, and we're going to link it to our coordinate geometry, your x and y axis. Okay, your coordinate geometry, x and y axis. Okay, we don't need to label that. All right, so how do you draw the triangle? So a lot of students can't remember how to draw the triangle. So I always advise them to remember a ribbon. You see, this is how a ribbon looks like, right? Okay, so we're going to draw in the second quadrant. So second quadrant, it will go this way. Okay, all right, and then the right angle triangle will be here. Obviously, the right angle triangle must be there because the longer side is this guy. The hypo is the longer side. So the hypo is the one that's opposite the right angle triangle. Okay, having done that, let's label where our angle is supposed to be, angle A. Okay, remember it's in the anti-clockwise direction, so that's my angle A. So this little angle here is called your basic angle, alpha. Okay, if you've forgotten what is alpha, I will do a video on that. Okay, so now let's label all the three sides. So that will be your opposite sides. This is your A, this is your H. Okay, right. So we are given the ratio for sine A to be half. So to find sine of an angle is to take the length of the opposite side over the length of the hypo. So in this case here, it would be 1/2, 1 unit over 2 units. Okay, so we're going to, your hypo will be 1. Maybe I should put this bracket. This is bracket. And then let me write it properly. So that is 1. Then your hypo is 2. So that leaves us to find the length of the adjacent. And so because if it's a right angle triangle, we will use Pythagoras theorem. So if we were to recall, Pythagoras theorem is a squared plus b squared equals to c squared. All right. So we know the longer side is c, which is 2 units, so 2 squared. And we want to find a, so let's the adjacent side be the small letter a. So we want to find a, and let opposite be the letter b, so 1 squared. So a squared will be 4 minus 1. 2 squared is 4, so 4 minus 1 gives you 2 squared minus 1 squared, so that gives you 3. So a will be square root 3. Okay, right. But you don't put square root 3 because we were actually talking of linking this to coordinate geometry. So for coordinate geometry, on the left side, this one here, it will be a negative value, right? So you need to put a negative in front of your square root 3. Okay, so we have this beautiful diagram ready. So from there, we can find the value of cos A. So cosine will be ka, A over H, A over H. And that will give us negative square root 3 over 2. Okay, so we're going to keep that. So now the next thing is that I have to draw the diagram for angle B. I'm going to use a different color. Let's use black. So let's draw. Again, it's in the second quadrant. So this is how your diagram will look like. Angle B. Okay, so tangent is TOA. TOA. So tangent B will be O over A. So that will be negative 3 over 1. Okay, we don't know where the negative belongs to. It's the opposite of adjacent. Okay, so let's look at the diagram. Let's label all your. So this one will be H. This will be your O. This will be your A. Okay, right. So involve A. Involve A, and we say that on the left-hand side, right? On the left-hand side of your coordinate geometry, it's negative. So therefore, your negative will comes here, negative A. Okay, and opposite, it's above the x-axis, so it's a positive 3. Okay, that's how you get square root 3 over negative 1 gives you negative square root 3. Okay, and similarly, we're going to use Pythagoras theorem to find your hypo. Okay, to find your hypo. So I'm going to do it here. Right, So I have c squared. Sorry, we will use a squared plus b squared. So I would have a squared plus b squared equals to c squared. So I need to find, I need to find c. I need to find the values of c. Okay, so I should write it the other way, sorry. So I would have c squared equals to a squared plus b squared. So c will be, okay, let's do step by step. So a, you can let a be -1, let a be -1. So make sure you bracket it, bracket -1, because negative, it's 1 is a negative number, so bracket it. Then b is square root 3, and that will gives you 4. Wait, tangent b. Oh, okay, so that gives you 4. So c will be square root 4, gives you 2. So your hypo is 2. Let's put the number 2 there. Okay, 2. Okay, so from there we can find the values of cosine b. So cosine b is a over h, which gives you -1 over 2, negative half. Okay, negative half. So with this value, I can find cosine a divided by cosine b, and that will be negative square root 3 over 2 divided by bracket negative half. So that will gives you positive, negative divided by negative is positive. So square root 3 over 2 times 2 over 1, and that gives you square root 3 as the answer. From both diagrams we have drawn in 16 part 1, part I, right, you should be able to get all this ratio. Cosine b is negative half, cosine a is negative square root 3 over 2, sine b is square root 3 over 2. Okay, so let's substitute all this value into part 2, into the questions. Okay, let me show you what a common mistake that some students will make. They will substitute in like that. Okay, and I don't want to continue anymore. Okay, because it's not correct. Okay, the negative, okay, look at this guy here. Negative half is the ratio for cosine b. Think about it. How can the angle b be just be negative half? Does not make sense, right? Okay, so negative half is the value for the whole thing cosine b. All right, so this is incorrect. Better quickly erase it. Okay, let's don't learn the incorrect things. Let's learn the correct one. So the value for cosine a will be negative square root 3 over 2. Cos b will be negative half. Sine a will be half given in the question. Sine b from the diagram, we should be able to find the value, which is square root 3 over 2. Okay, so let's multiply them together. Okay, right, 2 is 2 over 1. So multiply numerator. So that, okay, negative times negative is positive. So that gives us 2 square root 3 times 1 will be just 2 square root 3. Multiply the denominator, that gives us 1 times 2 times 2, that gives us 4. Do the same thing for the other one. All right, so we have 2 square root 3 minus 1 square root 3. So that gives us square root 3 over 4. Don't forget your denominator. Okay, if you cannot handle that, that's one way you can do is just to factorize your square root 3 out. Okay, factorize square root 3 over 1, so you get 2 over 4 minus 1 quarter. And 2 over 4 minus 1 quarter is 1 quarter. So that will be 1 quarter times square root 3 over 1 give you square root 3 over 4. Okay, that will be the answer. So question 17 is more challenging than question 16, because in question 16, the questions told you where the angle A and B, which quadrants the angle A and B can be found. Right, but in question 17, you do not know. So you have to deduce it yourself. Right, so we will have to link this to the first slide in the video. Okay, the first slide that will explain about your ASTC. Okay, So using your ASTC, let's deduce where your sine theta, what value your sine theta will obtain. It has to be a negative value. Less than 0 means a negative value. That means the trigonometric ratio for your sine of this angle is a negative. And to get a negative value, it can only happen in the third and the fourth quadrant. Why? Because in the third quadrant, okay, let's label the angle again. This in the anti-clockwise direction. In the third quadrant, it's between 180 to 270. Only tangent, the trigonometric ratio of tangent of this angle between 180 and 270 is positive. All right, for sine and cosine is negative. So for sine theta to be negative, it can happen in third or fourth, because at the fourth quadrant only cosine, the ratio is positive. Okay, right, third or fourth. All right, then for cosine theta, let's now go back to cosine theta. So cosine theta is a positive value. Okay, cosine theta given to be positive. So for cosine to be positive, it can only happen in the first quadrant and the fourth quadrant. Okay, so if you're talking about the same theta, same angle, we're talking about the same angle, right? Cosine theta, theta. So if you're talking about the same angle, then the quadrants that this angle theta must be in will have to be an overlap of 1 and 4 and 3 and 4, right? Right, so the overlap one would be at the fourth quadrant. Okay, so this is how we deduce where the angle theta must be in. Okay, so having known that already, we can draw a diagram. Remember the ribbon, okay? So this is your right angle triangle. This one is your hypo. This will be, your angle will be travel in the anti-clockwise direction, theta. This will be your opposite, and this will be your adjacent. Okay, so now we can put in your ratio, cosine. So for cosine theta, cosine is car A over H. So your A will be 1 unit, your H will be 3 units. Okay, so we can put in A to be 1, H to be 3. All right, and then it's a positive one because it's on the left side, on the right side of your coordinate geometry. And this is the if you're talking about unit circle, this is the radius of the circle. Radius of a circle is always positive. You can't draw a circle with a negative value. Okay, and then okay, so we need to use Pythagoras theorem to find the opposite side, right? So that will be a squared plus b squared equals to c squared. So that will give us a, if you let the opposite side be the letter a, then it will be c squared is 3 squared minus 1 squared. So a will be square root 8. Okay, and then square root 8, we can actually simplify it. You can simplify it first because after all you need to rationalize it later. So if you apply the surds that I've learned earlier on is square root 4 times square root 2. So square root 4 is 2. So square root 8 can be simplified into 2 square root 2. Okay, now, so but the opposite side is not 2 square root 2 because you're talking about this length, this value that is below the x-axis, because we're linking it to coordinate geometry. So below the x-axis will be negative value. So hence that will be negative 2 square root 2. Okay. All right. So from there we can get your values of tangent theta and also sine theta. So from there, tangent theta. Okay, maybe I'm going to erase this. We don't need this one. All right, so we can find tangent theta to be tangent, it's O over A, and that will give us opposite, it's negative 2 square root 2, adjacent is 1, also negative 2 square root 2. Okay, very good. Right, so part, okay, wait, then we can find sine theta. Sine will be O over H. So that will give us negative 2 square root 2 over H, which is 3. Okay, so with that, we can find part 1. So part 1 is cotangent theta. So cotangent theta is 1 divided by tangent theta. So that gives us 1 divided by negative 2 over square root 2. Okay, if that is the case, it's better to write it this way. 1 over tangent theta. 1 over negative 2 square root 2. Okay, so we have to rationalize it. Just multiply by square root 2 at the denominator, also at the numerator. So that will give us negative square root 2 over negative 2 times 2. Negative square root 2 over 4. Okay? Because square root 2 times square root 2 is 2, then 2 times another 2 is 4. Alright, then part 2. Cosecant theta, that will be 1 over sine theta. So that will be 1 divided by negative 2 square root 2 over 3. Change your division division sign to multiplication will be 1 times bracket negative 3 over 2 square root 2. Okay, and then I'm going to continue here. So that will gives you a negative 3 over 2 square root 2. So we need to rationalize it. So that will end up getting 3 square root 2 over 4. This is a slightly harder questions than the previous two that we have done, because the 3 conditions that we need to satisfy. Okay, 3 conditions. So let's look at this tangent B first, and sine B. Let's look at these 2 conditions first because they refer to the same angle B. All right. So let's write down your ASTC. Write down the ASTC. Okay, in the anti-clockwise direction. Okay, so for sine B to be a negative value, it can only happen in the 3rd or the 4th quadrant. And for tangent B to be positive, it can only happen in the first and the which quadrant? 1st and the 3rd. Okay, right. So now let's look at cosine A. So cosine A, it's negative. So for cosine A to be negative, it can only happen in the 2nd or 3rd quadrant. All right. Okay. So if you look at it, right, if you look at it carefully, right, you are told that A and B must have to be in different quadrants. So if you're going to choose quadrant 3, then that's not correct, right? Because if you choose quadrant 3, means they are all happening in the 3rd quadrant, which the questions does not require you to be in the same. The question requires you to be in different quadrants. So for tangent B, and to satisfy tangent B and sine B, we know we have to be in the 3rd quadrant, right? Right, and then to be a different quadrant from cosine A, you cannot choose the 3rd quadrant. You have to choose a different quadrant. So in this case here, you have to choose quadrant 2 for your angle A, then quadrant 3 for your angle B. Okay, so angle B will be in the 3rd quadrant. Let's draw the diagram, 3rd quadrant. Okay, so let's label all the sides. So this will be your opposite, this will be your hypo, and this will be your adjacent. Right, so tangent B, to find tangent B, we take the length of O divided by the length of A. So that will give us 3 units over 2 units. Okay, if you look at the diagram, observe that this portion here we're talking about is below the x-axis. So you need to put the negative to the letter 3, to the number 3. Then likewise for this, it's on the left side of your y-axis, so it's a negative value also, so that will be -2. And then to find your hypo, you can just use Pythagoras theorem, which is c squared equals to a squared plus b squared. So that gives us bracket -3 squared plus bracket -2 squared, and that will give you 13. So c will be square root 13. So this is square root 13. Okay, so from here you're able to find the value for cosine b. Okay, so we can do part 2 first. So part 2, secant b, okay, is equals to 1 over cos b. One way to remember it is to just look at the third letter. Right, third letter. It's a letter C, so 1 over cos b. So it's 1 divided by cosine b, which we found it to be, where we can find it to be cosine. It's okay. Let's try to write it here. So cosine b, it's a over h. So a is -2 over h is square root 13. So it's equals to 1 divided by bracket -2 over square root 13. Change the division sign to multiplication, that will give you negative square root 13 over 2. Okay, so that's the answer for part 2. Okay, so for part 1, we will have to draw the diagram. We continue in the next slide. Agreed that angle A will be in the second quadrant, so let's draw the diagram in the second quadrant. Okay, so cosine A is equals to A over H equals to -1 over 4. Alright, so let's label all the sides. This will be opposite, this will be A, this will be hypo. Okay, right, so adjacent, right. So again, this one has to be a negative value because it's on the left side of your y-axis. So this one will be -1. Your hypo is actually the radius of the unit circle. Okay, so the radius of the unit circle is always a positive value. So when you draw a circle, all right, so your hypo here is actually the radius, okay, the radius of your circle. Okay, so the radius of a circle is always a positive value, right? So that will be +4. Okay, you can use Pythagoras theorem again to find the opposite side, and that will be square root 15. Okay, so from here I can find the values of sine A. Sine A will be 4 over h. So that's square root 15 over 4. Okay, so part 1, to find cosecant A. Alright, look at the third letter. The letter is letter S, so 1 over sine A. So that is 1 divided by square root 15 over 4. Change the division to multiplication, so it's 4 over square root 15. Rationalize it. So that gives you 4 square root 15 over 15. That's the answer.